Okay, hello everybody. Today's lesson is going to cover how to measure angles using a protractor and just kind of angle measurements in general. Okay, so in geometry, let's go ahead and start with our notes here. In geometry, angles are measured in units called degrees. The symbol for degrees, well, the symbol for angles, I'm going to show you that. I'm going to show you a couple different things here. You got the angle symbol. It's always that symbol. It doesn't matter what kind of angle it is, but you're going to see that, and it might be denoted by one letter, or sometimes you'll see angle, where there's three letters, A, B, C, something like that, and I'll address that in just a second. But I think what these notes are trying to get at is that sometimes we use that little symbol. If something is 75 degrees, obviously use superscript a 0 right above there, and that denotes that we're talking about degrees. So an acute angle is an angle that is greater than 0 degrees, put the little degree sign there, but less than 90. So it's somewhere between 0 and 90, cannot be equal to 90. And examples of acute angles, sometimes, they're always pointing one way. You might always see kind of a typical acute angle that looks like that, but they can be any which direction. They can look like this, as long as they're less than 90. And you remember, a 90-degree angle looks like this, and I'm just freehanding it. That looks like that's a 90-degree angle. That's not what we're going for here. We're going for less than that. So it could be way less, it could be really, really tiny, or it could be almost 90. Something that's pretty close. That's almost 90. That's probably 80 something or 70 something, probably 80s. But those are examples of acute angles. You might have had teachers that have taught you that, acute angles are they're acute angles. They're small, tiny angles. That's one way to remember them, I guess. If that works for you, go ahead and use that. An obtuse angle is an angle that is greater than 0 degrees, but less than 180. So they open up a bit wider than a 90-degree angle. Not just a bit, but sometimes a lot. But these are examples of obtuse angles. And I should also make sure you guys know what I'm talking about. Like that part of the angle is obtuse. This angle is kind of barely obtuse. I kind of made that look almost like it was 90 degrees. And sometimes you'll have angles that appear to be almost straight. And this angle, I'm not going to make that perfectly horizontal, but if I'm talking about that section of the angle, those are all obtuse angles. They're all greater than 90 degrees. They're all between 90 and 180 degrees, somewhere in that range of numbers. So a right angle, you probably already knew this, but a right angle is exactly 90 degrees. And examples of right angles are pretty easy. Actually, there's right angles on this page right here, where these lines intersect. Those are right angles. Right here is a right angle. There's right angles everywhere you look, really, where the wall meets the floor, where the ceiling meets the wall. If you look at your tiles, those are 90-degree angles. But 90-degree angles are exactly 90 degrees, and usually they'll be indicated as such with a square in the corner. You might have a geometry teacher later, especially when you get in high school, that might say, never assume a right angle unless you see that little square, or if you see the word, the number 90 degrees written in there. A straight angle is exactly 180 degrees. And straight angles, there's not a lot of examples I can draw of that. Let's say that's the vertex right there, but straight angles are exactly how they sound. They're straight. They're 180 degrees. So a straight angle is 180. Now, there's another angle too, if you're wondering. There's one type of angle. Maybe you guys can figure that out. What is a reflex angle? Look that up and tell me what you think that is. Maybe in the comments, see if you guys can figure out what a reflex angle is. It's not really a 7th grade thing, but it's definitely something you can kind of look up and see if it makes any sense to you. Okay, now let's move on to measuring angles with a protractor. Now this is an E-lesson. This is a video lesson, so it's kind of hard to do this when you don't have your own protractor. But when you guys use your IXL assignment, or when you guys do these online, a lot of times, especially with the way technology is now, they can kind of throw a protractor up there on the screen, and you can kind of manipulate it and turn it, rotate it, and get it to where you need it to be so that you can measure the angle yourself. A lot of times, actually, if you really think about it, everything you know about the angle is kind of right there in front of you. Sometimes I think when people put down a protractor on their paper, it ends up screwing them up a little bit because of the way a protractor looks. You know, this is a protractor right there, and you might notice that a protractor has two sets of numbers. You know, there's 110 here and there's a 70 here. And the most common question I ever get with measuring angles is, you know, Mr. Alvaro, they'll say, what number do I use? Is it 110? Is it 70? Which one is it? And then that's where kind of you have to just use logic a little bit and use a little bit of reasoning and eyeballing it, and just looking at the angle itself. I always tell people, before you even lay down a protractor, even before you lay it down, decide what kind of angle you're dealing with. And if you look at this kind of angle right here, you can tell just by, like I said, just by eyeballing it. You can look at this angle and just go, oh, I know that that's acute. And if it's acute, we know that it's between 0 degrees and 90 degrees. We know it's somewhere in that range. It's obviously not 0. It's obviously not 90. It's probably in between that, like maybe in the 40, 50 range. But I'm just guessing, but I'm using an estimate here. That's important. Being able to kind of just estimate and determine what kind of angle you're dealing with in the first place is really important. And when we measure an angle, we're talking about how much does that open, okay? So let's talk about the parts of an angle here really quick. The part of an angle that where the angle starts is called the vertex. You got the vertex here. And then you have rays that extend from each vertex. And a lot of times, sometimes, I should say maybe not every time, but a lot of times you'll see letters that are labeled on the rays, and there might be a letter labeled at the vertex. The letters help you kind of label what the angle is. You have to write down all the different ways that you can describe this angle. And let's kind of do that first before we even measure it. Before we even measure it, we can look at this and go, okay, well, I'm going to use the angle symbol. So that's angle. All right, and there's one, I, D, K. So that's one way to kind of say what the measurement of that angle is. You could say angle KDI. That's another way. That's the second way. And another way to label this angle, and we can get away with it with this particular angle, is that we can just label it by its vertex. We can just say, well, angle D, because that's the only letter that is there. Sometimes when you're dealing with angles, though, let me kind of move up here. When you're dealing with angles, or you're going to have angles that are overlapping or intersecting over each other, and you can't just get away with saying, well, this right here is angle B, because what angle B are you talking about? Are we talking about that angle B? Are we talking about this angle B? Or perhaps we're talking about the entire thing. So it's not specific enough to just say that that's angle B. We want to be careful with how we write that down and how we label that. So for instance, if I wanted to label this angle right here, the one that I'm kind of shading in, and I'm doing kind of a hack job here of shading it all in, but that we can call that angle ABC, or we can also call that CBA. Now another thing, I don't think I said this, but one thing that's really important when you label an angle is that you always put the vertex, whatever letter represents the vertex, always goes in the middle. That must go in the middle. If it's not in the middle, then you're not doing it right. So that B, notice in both of those examples, that B is in the middle. And in the example that we talked about earlier, notice the D is in the middle. And actually, the D is the one that's used when we're labeling it by itself because there's only one angle there. Okay, so back to this example 1 here. Let's get to measuring. And like I said earlier, we know we're dealing with an acute angle, all right, which is important because I think when you lay down your protractor, that's good to know. So I'm going to grab my protractor here. Okay, let me just kind of make some comments here before we go too far with this protractor. Now, protractors depends on which protractor you're using. A lot of times, though, this point right here, sometimes there's a dot there, sometimes there's a hole in your protractor, sometimes there's nothing there other than maybe just kind of two lines that intersect, like in this example. You want to put your vertex of your angle on that point. One of these lines right here is either pointing at 0 or 180. And that's 0, 180. You can have that flush along that line. But yeah, you want one of the rays along one of those lines. Okay, so now when I put the protractor here, I'm going to get that point on the vertex right there of the angle. And then this angle right here is already kind of laid out nicely for us. We don't actually have to do anything with the protractor itself. So I'm going to get that right there. Okay, so now that I have the protractor overlapping the angle, I'm going to look at the measurement here. And again, like I was saying earlier, the confusing thing about a protractor is that there's always two sets of numbers, because the thing that you have to remember about a protractor is that we're not always measuring angles this way to, from top to bottom or bottom to top. Sometimes we're measuring angles every which way. And so we have to kind of decide and use good critical thinking here to think about what number makes the most sense. And in this case, 40 is probably the number that I'm going to use, not 140. Because 140 would indicate it was obtuse. We can automatically cancel that out. So it looks like it's almost like 41, but I'm just going to go with 40 because it's pretty close to that. And then I'm going to write down as my answer. Okay, so this angle right here, angle IDK equals 40 degrees. And we're not going to do this every time, but there are a lot of different ways you can write that. You can say angle IDK, you could say angle KDI equals 40 degrees, or we could say angle D equals 40 degrees. Angle D is the easiest way to do it, but like I said, you can't always get away with that. Okay, now moving on to example 2 here. Let's do what we did before, which is just kind of get a general idea of what kind of angle this is. And you can tell, again, it doesn't take a lot of, you don't have to put your instrument down. You can just go ahead and look at it and just think, oh, what kind of angle is it? And it definitely looks like we're dealing with an obtuse angle, meaning that it's greater than 90, less than 180. So I have fairly good confidence here that we're dealing with an obtuse angle. And that's good to know. So now I'm going to take my protractor tool and then I'm going to put it on that angle as best I can. I think since I'm using a computer here, things don't always lock into place like you want them to. Yeah, everything kind of worked out nicely here. Now if you look here, my angle here, it goes through 60 and it also goes through 120. So one of those numbers works, another one of those numbers does not work. We've determined that it's obtuse, so 60 is the number that we're probably not going to go with. We're going to definitely go with that angle being 120 degrees. So there you go. So this angle right here, angle OMG, equals 120 degrees. All right, going on to the next example. I threw this one on here because your IXL is going to throw some angles at you that are not perfectly straight, where one of the rays is not perfectly horizontal. It's going to be like this, and it's going to give you a protractor that's on top of it that isn't necessarily rotated. It's just there, and you have to figure out what it is. Let me kind of show you how to do that. So first of all, let's look at this angle and let's kind of come to a determination that it is acute. So we can make a fairly confident choice here that we're dealing with an acute angle, meaning it's between 90 and 0 degrees. It falls somewhere in that range. Okay, so now this is what I'm talking about right here. And like I said, when you're doing this online, your IXL problems are going to be thrown up on the screen, and you're not going to have the opportunity to rotate your protractor at all. I can rotate mine if I can rotate my protractor like this, but I'm not going to do that. I'm going to keep it this way so that kind of show you how this works. So that if you don't have to rotate it, let's see what we have to do. So like I said, we determined that it's acute. And then you might also notice that it goes through a few numbers. You know, it goes through 60, and it also goes through, looks like 130 right there. So some people might say, well, what is it? Is it 60 degrees? Is it 130 degrees? And the answer to that would be, well, neither, just because one of those rays goes through it. Remember, what we're looking at when we're doing an angle is we're looking at how wide does it open. We're looking at this part of the angle. What is that region? You know, how many degrees does it open up? And that's the most important thing. So those numbers, although I said 60 and 130 are not our answers, those numbers do actually help us if you think about it. Because, and I'm just using the top row of numbers, 60 and 130. But if you take those numbers, 130 and take away 60, if you do that, you're going to get 70 degrees. And that is 70 degrees. And we can kind of prove that. If you don't feel like subtracting that, you can always just look at and just kind of piecemeal it. If we can look at, okay, from here to here, that's 10 degrees. All right, there's another 10 degrees. There's another 10. And you don't have to go by 10, but I'm just doing this just to break it down a little bit. And then you'll notice that we've got 7 10s. So we've got 10, 20, 30, 40, 50, 60, 70 degrees there. So I could say that that's a 70-degree angle there for sure. No doubt about it. Okay, so now we're ready to write down what the measurement of this angle is. So angle AYS equals 70 degrees. And then for the last example, we're doing the same thing. Again, we're going to throw our protractor down on the angle, and it's not going to, I'm not going to make it line up perfectly with one of the rays. I want to just get this vertex on that point where I want it to. Ugh. Let's get that right there. All right, that's good enough. You're going to notice that it goes through, and I'm just looking at the top set of numbers. And that sometimes too is something people ask me, and you don't have to use the top set of numbers. And that's a question I get, like, do I use the top or do I use the bottom? And really it depends on what the angle is. And I should have gone over this before we put the protractor down, but we know for sure that this is an obtuse angle. It's greater than 90, less than 180. It's between 90 and 180. So if I use the wrong numbers perhaps, and I get a number that is like, let's say I get 70 degrees, or if I get 20 degrees, then that logic doesn't pan out, because I know, just by looking at that angle, I know that's obtuse. We know, just by looking at it. Again, there's a lot of stuff, I think sometimes when you put down the protractor, when you lay that down on your page, I think that sometimes messes with people, because they are kind of a confusing instrument to use because of all the numbers, and they go every which direction, and there's 2 sets of them, and that's always a thing that confuses the heck out of people because they don't know which number to use. But like I said, just determine what kind of angle it is, and then when you get your measurement at the end, if it pans out and if it works out with what you've determined beforehand, then it's got to be it. I'm going to take down those numbers. I've got a 20 degrees, and I've got over here 170 degrees. And if we take the difference of those numbers, 170 minus 20, that is going to equal 150 degrees. So that is 150 degrees. And we could prove that by just kind of, again, we can go by tens. Right here, that's 10 degrees. Here's 20. Here's 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and 150. This angle right here opens at a 150 degree angle, which everything, that makes sense with the numbers that we got. And let me just kind of show you that it doesn't matter what numbers we use. You know, I think for both my examples, I used the top numbers, but let's say we use the bottom numbers. Right here, we have 160, and right here, we have 10. So if we take the difference of those numbers, 160 minus 10, we end up with the same result. We get 150 degrees again, which is what we got before. So there's your angle. Your angle is right here. Angle FRT equals 150 degrees. You can also write angle R equals 150 degrees. You can also write angle TRF equals 150 degrees. I'm not asking you to write them all three ways. I'm just showing you that there's a lot of different ways you can write it. Okay, so that does it for your lesson on measuring angles. This wasn't too bad. Hopefully this wasn't too confusing for you and I didn't say anything that didn't make any sense. Or I hope I didn't say anything that was wrong. I think yesterday, I forgot that I said this, but let me just make sure this is clear. I think I said for the triangle inequality theorem, I accidentally said that the numbers have to be the two smaller angles, you know, whatever they are, the two smaller angles. Let's say we have 4 and 2, and then this number right here is 6. Well, I said the two smaller angles have to be greater than or equal, and I was wrong. I did not mean to say that. I think I went the whole lesson. I said that I totally having a brain fart there. But yeah, it's got to be those numbers right there. They've got to be greater only. They must be greater. And 4 and 2 is not greater than 6. 4 and 2 is equal to 6. So if this was, for instance, like let's say it was like 4.1, you know, if that's 4.1 and 2, well, that makes a sum of 6.1. So that actually makes a number that's greater than 6. But yeah, I think I said, I kept on writing, I didn't notice this until later. I think someone made a comment and I'm like, I watched the video, I was like, oh, I said that the entire video. So I apologize, but I wrote that symbol when I should have really just been writing the greater than sign. So I apologize for that. I owe everybody $1 or a brownie or something for doing that. If I ever see you guys again, come by and pick up a brownie for being annoyed by that detail that I didn't do on there. But anyway, that does it for your lesson. Everyone have a great day. We're not going to have a lesson on Friday. And make sure you guys are keeping up with all the stuff and checking in with me, letting me know if you're not understanding something. And that's it. Everyone have a great day. Take care.